Question number 33. Each of the plates shown in the figure has surface area 96 upon epsilon naught into 10 to the power minus 12 farad meter on one side, and the separation between the consecutive plates is 4 millimeter. The EMF of the battery connected is 10 volts. Find the magnitude of the charge supplied by the battery to each of the plates connected to it. So here, since this is connected to positive terminal of battery, so it will have positive charge on both sides, plus, plus, plus. Here also plus. So it is better to write the charges here. There is sufficient space. This will be plus, 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 and here there will there, it will also be plus, 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 plus. Then due to induction, there will be sign here minus, 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 minus. And since this charge, this plate is not connected, so that charge will be zero on it. So same amount of positive charge will be put here. Similarly, here there will be negative sign, and there will be equal positive sign on other side. And this is connected to negative terminal of battery. So on both sides, negative charge will be there. Now we can find the capacitance of one capacitor. So C is equal to epsilon naught A divided by T. So epsilon naught. Area is given as 96 divided by epsilon naught into 10 to the power minus 12 divided by T separation 4 millimeter, 4 into 10 to the power minus 3. So this will give 24 into 10 to the power minus 9 farad. Now, these three capacitances are connected in series. So equivalent capacitance, C equivalent will be equal to 1 by 3 of C, as you know. 1 upon C series will be 1 upon C1 plus 1 upon C2 plus 1 upon C3. And since all three capacitances have equal capacitance, since all three capacitors have equal capacitance, so it will be C by 3. That is 24 by 3 into 10 to the power minus 9 farad. So that is equal to 8 into 10 to the power minus 9 farad. Now, charge Q equal to CV. So here C is 8 into 10 to the power minus 9 into voltage is 10. So that is 8 into 10 to the power minus 8 coulomb. And now, charge on each plate is this is charge on one side. Now charge on each plate. So will be double of it because this charge is on one side, so will be equal to 2 times 8 into 10 to the power minus 8. That is 16 into 10 to the power minus 8, or 0.16 into 10 to the power minus 6, which is equal to 0.16 microcoulomb. Now, let's go to next question. Question number 34. The capacitance between the adjacent plates shown in the figure is 50 nanofarad. C is given 50 into 10 to the power minus 9 farad. And a charge of 1 microcoulomb is placed on the middle plate. So here 1 microcoulomb charge placed between the plus, 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 plus here also plus, then here it will minus, 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 and here it will be plus, 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 plus. The same will be here minus, minus, right here plus, plus. Now we saw the charge distribution. On upper plate, it will be 0.5 microfarad. Here, minus 0.5 microfarad. Here, it will be 0.5 microfarad. Sorry, it is charged, not microcoulomb. And this is also 0.5 microcoulomb. Send us to here, minus 0.5 microcoulomb. And this will be plus 0.5 microcoulomb. Now, here our question, what will be the charge on the outer surface of the upper plate? Which is clear that charge on outer surface of the upper plate is plus 0.5 microcoulomb. Now, second part, find the potential difference developed between the upper and the middle plate. So, Q equal to CV, from where we get V equal to Q upon C. The charge we have got 0.5 into 10 power minus 6 divided by capacitance is 50 into 10 to the power minus 9. So, if we simplify, we will get 10 volt. Now consider next question. The capacitance between the adjacent plates shown in the figure is 50 nanofarad. C is given 50 into 10 to the power minus 9 farad. A charge of 1 microcoulomb is placed on the upper plate. Here charge is given 1 microcoulomb. The situation will be right plus plus plus. If we write its value, so this will be 0.5 microcoulomb, and on this side also it will be 0.5 microcoulomb. Then here negative sign, and it will be minus 0.5 microcoulomb. Then on other face, it will be plus 0.5 microcoulomb. Similarly, here it will be minus 0.5 microcoulomb, and on this surface, it will be plus 0.5 microcoulomb. Now, our purpose is what will be the potential difference between the upper and middle plates and the middle and the lower plates. So let's evaluate it. So potential difference B is Q upon C, and Q is 0.5 for upper plate, 0.5 into 10 to the power minus 6 divided by capacitance is 50 into 10 to the power minus 9. So this will give 10. Now, since here what we observe, charge distribution is alike. So the middle and the lower plates will have also same potential difference. Same value Q upon C 0.5 into 10 to the power minus 6 upon 50 into 10 to the power minus 9, which will give 10. Now consider question number 36. Two capacitors of capacitances 20 picofarad and 50 picofarad are connected in series with 6 volts actually. Find the potential difference across each capacitor and the energy stored in each capacitor. So first of all, let's evaluate here what is total capacitance. Total capacitance will be C equivalent, it will be 20 into 50 into 10 to the power minus 12 into 10 to the power minus 12 divided by 20 plus 50 into 10 to the power minus 12. So this is C. Now we have to find out what is charge. So Q will be equal to C equivalent into this. C equivalent is this much. So here this will be 1000 divided by 70 into 10 to the power minus 12. We have to put into voltage is 6. So this will become 600 divided by 7 into 10 to the power minus 12 coulomb. Now we have to find out voltage. So V1, when you across first capacitance is V1, and there it is V2. So V1 equal to Q upon C1 So doing this much, 600 upon 7 into 10 power minus 12 divided by C1 is 20 picofarad, 20 into 10 to the power minus 12. So this becomes 30 upon 7 volt. V2 equal to V minus V1. So V is 6 minus 30 upon 7. That is 12 upon 7. Energy stored in each capacitor. So energy stored in first one, U1 is half C1 V1 square. We put the values 1 by 2. C1 is 20 into 10 to the power minus 12 into V1, so that is 30 upon 7 whole square. If we evaluate it, it comes out to be 184 picojoule. Similarly, so this is U1. Now energy stored in this capacitor will be say U2 is half C2 V2 square 1 by 2 and the C2 is 15 into 10 to the power minus 12 into voltage is 12 by 7 whole square. So it will come out to be 73.5 picojoule. Now let's go to next question. Question number 37. It says two capacitors of capacitances 4 and 6 microfarad connected in series with a battery at 20 volt by the energy supplied by the battery. So let's calculate the energy supplied to each plate and then answer will be double of it. So here, let's find out equivalent capacitance. C equivalent will be equal to 4 into 6 divided by 4 plus 6 microfarad. That will be equal to 2.4 microfarad. If we calculate the charge Q equal to C equivalent into V, so this will come out to be 2.4 into 10 to the power minus 6 into 20. That is 48 microfarad. Now, our purpose is to get first voltage, then energy stored. So V1 if we find Q upon C1. So this will be equal to 48 into 10 to the power minus 6 divided by 4 into 10 to the power minus 6. So that will be 12 volt. And then V2 will be 20 minus 12, that is 8 volt. Now energy stored. So U1 equal to half C1 V1 square and U2 equal to half C2 V2 square. Let's evaluate. So U1 equal to half C1. C1 is 4 into 10 to the power minus 6 into voltage is 12 square, which will become 288 into 10 to the power minus 6 joule, and U2 will be 1 by 2 into C2. C2 is 6 into 10 to the power minus 6 into V2, that is 8 square. So this will become 192 into 10 to the power minus 16. So total energy U will be sum of U1 plus U2, and that will be 480 into 10 to the power minus 6 joule. As I told you, this is energy supplied to each plate. So energy supplied by the battery, both the plates will be double of it. So total energy supplied by the battery will be just double of it. That is twice of 480 multiplied by 10 power minus 6. That is 960 microjoule. Also, in other way around, we can say that half of the energy supplied by the battery is lost in form of heat. Thank you for watching.